Far from any coastline, hidden beneath the vast blue surface of the Pacific Ocean, a silent transformation is underway. There are no towering waves to warn us, no giant storms visible from space, no dramatic signs that would immediately capture global attention. And yet, thousands of kilometers across the tropical Pacific, an enormous reservoir of heat is slowly gathering strength. Scientists have been tracking it for months. Satellites have detected unusual changes in ocean temperatures. Deep beneath the surface, warm water is spreading eastward. Atmospheric patterns are beginning to shift. Trade winds that normally help stabilize the climate are weakening. Individually, these changes may not seem alarming, but together, they point toward the possible development of one of Earth's most powerful climate phenomena, El Niño, a natural event capable of influencing weather patterns across nearly every continent on the planet. And according to some of the latest climate projections, the conditions now developing in the Pacific Ocean could lead to an exceptionally strong event during late 2026 and into 2027. If that happens, the consequences could be felt everywhere. From devastating droughts in some regions to catastrophic floods in others. From record-breaking temperatures to disruptions in agriculture, ecosystems, and global economies. This is not simply a story about weather. It is the story of how a single ocean can reshape the climate of an entire world. And right now, that story may already be beginning. To understand why scientists are paying such close attention to the Pacific, we first need to understand how El Niño works. Under normal conditions, powerful trade winds blow from east to west across the equatorial Pacific. These winds act like a giant conveyor belt.
They push warm surface water away from the coast of South America and toward Indonesia and Australia. As warm water moves westward, colder water rises from the deep ocean to replace it near South America. This process, known as upwelling, is incredibly important. The cold water that rises from below carries nutrients that support some of the most productive marine ecosystems on Earth. It also helps regulate global climate patterns. When this balance remains stable, scientists refer to the system as ENSO-neutral. ENSO stands for the El Niño Southern Oscillation, a natural cycle that shifts between neutral conditions, El Niño, and its cooler counterpart, La Niña. Most of the time, Earth exists somewhere within this cycle. It has been occurring for thousands of years, long before industrialization, long before modern civilization, long before humans understood that such a system even existed. But every few years, something changes.
The trade winds weaken, sometimes only slightly, sometimes dramatically. When that happens, warm water that had been piled up in the western Pacific begins moving eastward. The cold water upwelling weakens. Ocean temperatures start to rise. And gradually, a massive pool of unusually warm water develops across the central and eastern Pacific. That is El Niño. At first glance, a difference of 1 or 2 degrees Celsius may not sound significant, but on a planetary scale, it represents an enormous amount of energy. The Pacific Ocean covers more than 60 million square miles. Heating such a vast area, even slightly, requires extraordinary amounts of stored heat. And once that energy begins interacting with the atmosphere, its effects can spread around the globe. Jet streams shift, rainfall patterns change, storm tracks move. Regions that normally receive abundant rain can suddenly experience drought. Areas accustomed to dry weather may face severe flooding. Entire weather systems can be reorganized. In many ways, El Niño acts like a giant climate amplifier. It doesn't create weather from nothing. Instead, it redistributes energy already present within Earth's climate system.
And sometimes those redistributions become extreme. History provides several examples. The El Niño event of 1997-1998 is often regarded as one of the strongest ever recorded. Sea surface temperatures in parts of the Pacific rose dramatically above average. The result was a chain reaction of global consequences. Floods devastated portions of South America. Drought affected large areas of Southeast Asia. Wildfires spread across Indonesia. Agricultural losses reached billions of dollars. Millions of people experienced disruptions to their lives. Then, nearly 2 decades later, another extraordinary event emerged. The 2015-2016 El Niño. Once again, ocean temperatures surged. Once again, weather patterns shifted across the globe. And once again, records began falling. The event contributed to some of the warmest global temperatures ever measured. Coral reefs experienced severe bleaching. Drought intensified in several regions. Economic losses mounted into the trillions of dollars. These events demonstrated a simple reality. When the Pacific Ocean changes, the world changes with it. Now scientists are asking whether another powerful event could be forming. Recent observations suggest conditions are becoming increasingly favorable. Subsurface heat content throughout parts of the tropical Pacific has been rising. This detail is especially important because the ocean surface only tells part of the story. The real warning signs often develop below. Deep beneath the waves, vast quantities of warm water can accumulate long before they become visible at the surface. Think of it like energy being stored inside a battery. At first, very little appears to be happening. But once enough energy accumulates, the system can change rapidly. That appears to be what scientists are observing today. Several bursts of westerly winds have been detected across portions of the Pacific. These winds are important because they can trigger the movement of warm water toward the east. As they push across the ocean, they generate massive underwater pulses known as Kelvin waves. These waves are unlike ordinary ocean waves. They do not create towering walls of water. Instead, they transport heat, sometimes across thousands of kilometers. When Kelvin waves reach the eastern Pacific, they can dramatically increase sea surface temperatures. And once that process begins, El Niño development can accelerate. Satellite measurements have already captured evidence of these heat pulses moving through the Pacific. For climate scientists, such observations are impossible to ignore, because similar patterns were observed before some of the strongest El Niño events in modern history. The difference today is the background climate. Earth is already warmer than it was during previous decades. The oceans have absorbed enormous amounts of excess heat. Global sea surface temperatures have repeatedly broken records in recent years. This means any future El Niño event would not be starting from the same baseline conditions as past events.
Instead, it would be developing in a climate system already carrying unprecedented levels of stored energy. And that is what makes the current situation so significant. The Pacific is not simply warming. It is warming within an already warmer world. And if those trends continue, the coming months may reveal just how powerful that combination can become. If the signals currently emerging across the Pacific continue to strengthen, the world could soon witness something far more significant than a typical El Niño. The possibility that concerns scientists most is the development of an exceptionally powerful event, one capable of pushing global climate patterns into unfamiliar territory. But what exactly makes one El Niño stronger than another? The answer lies in the amount of heat concentrated across a specific region of the tropical Pacific. Scientists monitor ocean temperatures within carefully defined zones near the equator. When temperatures rise significantly above average for an extended period, El Niño conditions are declared. Most events remain relatively moderate. They alter weather patterns, influence rainfall, and contribute to warmer global temperatures. But every once in a while, conditions align in a way that allows the Pacific to release an extraordinary amount of stored heat. These rare events become climate giants. And it is those giants that leave lasting marks on human history. At the moment, some climate models suggest that ocean temperature anomalies could continue increasing throughout the second half of 2026. Forecast confidence naturally decreases the further scientists look into the future. The atmosphere is chaotic by nature. Small changes can influence outcomes months later. Yet despite these uncertainties, many of the world's leading forecasting centers are observing the same broad trend. The Pacific appears increasingly favorable for a major warming event. That alone is enough to command attention. Because when the Pacific changes, weather systems thousands of kilometers away often respond. One of the first consequences would likely be global temperature records. Even during average El Niño years, global temperatures tend to rise. The effect may appear modest on paper, often just a fraction of a degree Celsius. But when measured across the entire planet, that increase represents an immense amount of additional heat. In a world already experiencing record-breaking warmth, even a relatively small increase can have enormous consequences. Heat waves become more intense. Nighttime temperatures remain elevated. Energy demand rises. Water resources come under pressure, and vulnerable populations face increased health risks. Recent years have already demonstrated how dangerous extreme heat can become. Across multiple continents, temperature records have been shattered. Wildfires have expanded into regions previously considered relatively safe. Cities designed for historical climates are struggling to adapt to new realities. Now, imagine adding one of nature's strongest warming mechanisms on top of that trend. Suddenly, events once considered rare begin occurring more frequently, and records that seemed impossible only a decade ago become increasingly vulnerable. But temperature is only part of the story. Water may ultimately become the larger concern, because El Niño has an extraordinary ability to redistribute rainfall around the globe. Some regions receive far more precipitation than normal. Others receive dramatically less. This imbalance creates winners and losers. And unfortunately, the losers often suffer severe consequences. In South America,
Particularly along portions of the Pacific coast, warmer ocean temperatures can fuel intense rainfall events. Rivers swell beyond their banks. Infrastructure becomes vulnerable. Communities face flooding that can persist for weeks. Roads, bridges, and agricultural land may experience extensive damage. Meanwhile, elsewhere in the world, the exact opposite problem emerges. Australia frequently experiences increased drought risk during El Niño years. Rainfall declines. Soils dry out. Reservoir levels fall, and landscapes become increasingly vulnerable to wildfire. For farmers, these conditions create enormous uncertainty. Crop planning becomes more difficult. Livestock management becomes more challenging. Water supplies become increasingly valuable. A single failed season can ripple throughout local economies. And if drought persists, the consequences may extend far beyond agriculture.
Across Southeast Asia, similar concerns begin to emerge. Many regions depend heavily on predictable rainfall cycles. When those cycles weaken, entire communities can feel the impact. Hydropower production may decline. Water shortages can develop. Agricultural productivity may fall. Food prices can begin rising. And speaking of food, this is perhaps where the consequences of a powerful El Niño become most visible. Modern civilization depends upon a remarkably interconnected food system. Rice grown in one region may feed populations thousands of kilometers away. Wheat harvested on one continent influences prices on another. Coffee, soybeans, maize, and countless other crops move through a global network of trade. When weather disrupts production in multiple regions simultaneously, the effects can spread rapidly. History has shown that strong El Niño events often coincide with agricultural challenges. Drought reduces yields in some areas. Excessive rainfall damages crops in others. Transportation networks become disrupted. Storage facilities may be affected. The result is often reduced supply combined with increased uncertainty. Markets rarely respond well to uncertainty. Prices rise. Import-dependent nations face greater pressure, and vulnerable populations suffer first. For millions of families already living close to the edge, even small increases in food costs can create serious hardship. This is why international organizations closely monitor developing El Niño conditions. The concern extends far beyond weather forecasts. At stake are food security, economic stability, and human well-being. Another region facing significant uncertainty is South Asia. The annual monsoon is one of the most important climate systems on Earth. Its arrival influences the lives of billions of people. Agriculture, water supplies, energy production, and entire national economies depend upon its behavior. Strong El Niño events have historically been associated with weaker monsoon seasons in parts of the region. That relationship is not perfect. Every year is different. But the risk remains significant enough that meteorologists pay very close attention whenever El Niño begins developing. A weaker monsoon can reduce agricultural productivity. Reservoirs may receive less recharge. Groundwater resources come under greater strain. And economic pressures can increase throughout rural communities. For countries heavily dependent on seasonal rainfall, even modest disruptions can have far-reaching consequences. the oceans themselves would not escape unchanged. Marine ecosystems are highly sensitive to temperature variations. Many species have evolved within relatively stable environmental conditions. When those conditions shift rapidly, stress begins to accumulate. Coral reefs are among the most vulnerable. Corals live close to their thermal limits. Extended periods of unusually warm water can trigger bleaching events. During bleaching, corals expel the symbiotic algae that provide much of their energy. If stressful conditions persist long enough, entire reef systems can die. Previous major El Niño events contributed to some of the most widespread coral bleaching episodes ever observed. A future extreme event could place additional pressure on ecosystems already struggling with warming oceans. Fish populations may also be affected. Changes in ocean currents influence nutrient availability. Food chains can become disrupted. Commercial fisheries sometimes experience significant declines. Communities dependent upon marine resources may find themselves facing difficult challenges. And then there are storms.
One of the fascinating aspects of El Niño is its influence on tropical cyclone activity. The effect varies depending on location. In the Atlantic, stronger upper-level winds often make hurricane development more difficult. That can reduce overall hurricane activity. However, the Pacific frequently experiences the opposite outcome. Warmer waters provide additional energy. Storm development can become more favorable. Cyclone seasons may become more active. Some storms may grow stronger than they otherwise would have. The exact details remain difficult to predict months in advance, but the underlying physics remain clear. Warm oceans provide fuel, and fuel increases potential. Taken individually, each of these impacts is significant. Together, they reveal something larger. El Niño is not a single weather event. It is a planetary-scale reorganization of energy, a shift capable of influencing atmospheric circulation, ocean dynamics, ecosystems, agriculture, and economies simultaneously. That is why scientists continue watching the Pacific so carefully, because what happens there rarely stays there. As 2026 progresses, new data will continue arriving from satellites, ocean buoys, research vessels, and forecasting models. Each observation will help refine our understanding of what lies ahead. Perhaps the Pacific will stabilize. Perhaps conditions will weaken. Climate prediction is never perfect. But if current trends continue, the world may soon experience one of the most closely watched El Niño developments in modern history. And if that happens, the consequences will extend far beyond the boundaries of the Pacific Ocean itself. They will reach farms, cities, forests, rivers, coastlines, and communities across the globe. Because when Earth's largest ocean begins releasing its stored heat, the entire planet eventually feels the effects. The coming months may determine whether this developing event becomes merely another chapter in climate history, or one of the defining climate stories of the decade. And for now, all eyes remain fixed on the Pacific.